Hey there! So, let's dive into the problem we're tackling today. The issue at hand revolves around a situation where calculating the cumulative absolute velocity from an acceleration signal can lead to errors due to the handling of sign changes in the signal. This problem arises when the sampling rate is large, and the signal frequently switches between positive and negative values, impacting the accuracy of the velocity calculation. Now, let's talk about the solution to this problem. The approach involves optimizing the calculation of the cumulative absolute velocity using Numba. By reworking the integration process and parallelizing the computations, we can significantly improve the performance of the calculation. The optimize function efficiently handles the sign changes in the signal, ensuring a more accurate and faster evaluation of the cumulative absolute velocity. Taking a closer look at the performance comparison, we see a substantial improvement in the execution time. The optimized integration method outperforms the initial approach by a significant margin, showcasing the power of parallelization and optimized computation techniques. This enhancement results in a much quicker and more efficient process for calculating the cumulative absolute velocity. Expanding on the solution, a more generic integration approach is introduced to handle various types of integrals, such as np.abs, s, and np.squares. By utilizing a combination of interpolation and specialized functions, the generic integration method can adapt to different signal characteristics. This versatility allows for a unified approach to numerical integration, catering to a broader range of signal processing needs. To sum it up, we've explored how optimizing the computation of cumulative absolute velocity can lead to significant performance gains. By leveraging parallelization, specialized functions, and interpolation techniques, we've created a more efficient and flexible solution for numerical integration tasks. Thanks for tuning in. Remember to subscribe, like the video, and share your thoughts in the comments below. And as always, keep coding with a smile.